Today we'll be learning about 17.1 definite integrals. Okay, first and foremost, we just introduced to you the idea of a definite integral. So far, what we have been doing is the indefinite integral. Then we know that when you have an indefinite integral, there's an integration constant. So now there's something called a definite integral, means that there's a value there, so we don't need to consider that constant itself. So first and foremost, what do we use the definite integral for? So for example, given here, this is the curve y is equals to x squared as shown here. So if I want to find the area under the curve, what can I do? Okay, here what they show you here is that they draw these small rectangles. These rectangles, you add this 1 2 3 4, the area of these rectangles, it approximates the area under the curve from A to B. All right, but then if you draw smaller triangles, you notice that the white spaces actually become smaller and smaller. So this is what we are doing when we integrate from A to B. What we are finding, right, is we're drawing all these little tiny rectangles, and the addition or the sum of all these tiny rectangles will give you the area under y equals to x squared from the limits from A to B. So now that you know that that's what the definite integral is used for, to find the area under a curve, what we can see here is this. There are some notations that you need to learn. So when I integrate a function in x, right, from A to B, this is what happens. We will get the integral, then we put the limits there, then we will sub in the values. Alright, not to worry so much, but do learn the A, the method here, and B, the what I call the notation here, as I do example 1 for you, then you try it out yourself. So now first example is from example 1, which is in your textbook on page 116. So we first do the integration. So when you integrate, so now what we have is a curve, x squared minus 3x plus 4. So the curve, I can imagine, it will be something like this. Then what we're trying to do is to find the area under the curve from -1 to -2, this area over here like this. So this is what we are aiming to do when we are performing this. So now first and foremost, when I perform the integration, x squared integrated gives you x cubed over 3. Then 3x integrated gives you 3x squared over 2. The 4 integrated with respect to x is 4x. Notice that I've done integration. For an indefinite integral, we'll have the integration constant plus c. In this case, no, we don't have that because it's a definite integral. We actually have values. So we use these rectangular boxes, and then we put the limits there. So the limit is from -2 to -1. The lower limit is at the bottom. The larger value, the upper limit, is at the top there. Now what we'll do here is this. How do I use these values? See here. First I use the -1. So I substitute the -1 into all the x values. So I get -1 cubed over 3 minus 3x -1 squared over 2 plus 4 times -1. Alright, then I will just close it up with a bracket. Then I will always minus the substitution of the lower limit itself. So in this case, what we'll have here is -2 cubed over 3 minus 3 -2 square over 2 plus 4 times -2. I close the bracket. So now you know how to use the limits already. Then all that remains is to use your calculator, and if you do everything correctly, you get 10 and 5 over 6. Let me show you 1b and 1c now. For 1b, I'm integrating from 4 to 9. So first and foremost, let me simplify this. Is t to the power of half plus t to the power of -half with respect to t. Then if I start to integrate, t to the power of half integrated will give me t to the power of half plus 1 is 3 over 2. So divided by 3 over 2, you get 2/3 here. Similarly, for the other term, if -half plus 1 gives you half, then 1 over half gives you 2. So I get 2 t to the power of half. I close, and I put my limits 9 and 4. Do you remember what we need to do now with the 9 and 4? Similar to what I've introduced in part A, we put 9 to the power of 3 over 2 plus 2, 9 to the power of half. So basically, I'm just substituting 9 into the t. Then for this portion here, we close it up, we minus away, we use t equals to 4 in this case. What I get is 2/3 4 to the power of 3 over 2 plus 2 times 4 to the power of half. I close my brackets. If everything goes well, you use your calculator, and please do try to use your calculator. What you get is 14 and 2 over 3. Okay, now I'm going to try 1C with you. Okay, for 1C, all right, what we have here is integrating, okay, from 2 to 5, r to the power of 4 plus r over 2r cubed with respect to r. So what we can do here is first we simplify. So always try to simplify if possible. R to the power of 4 over r cubed is half r plus half to the power of r to the power of -2, and we're still integrating with respect to r. Then we just start the integration. Half r integrated will give you r. Sorry, I made an error here. Okay, give me a moment. Let me check where my okay, no error here. So what I have here is this. Okay, half r plus half r to the power -2. Okay, to make our life just a bit simpler, what we can do is, if you notice the common term here, which is half, so I can actually factorize half here and put 5 to r plus r to the power -2 with respect to r. Then I start to do my integration. So r integrated is r squared over 2, r to the power -1 plus 1, okay, divided by -1. So what I will get here is negative 1 over r, and the limits are 5 to 2. Okay, so what we do here is half. Okay, now we use the 5 value, so it's 5 squared over 2 minus 1 over 5. I'm substituting 5, r into 5 and 5 over here. Then what happens here is this. What I'll do here is to minus away. I will put here 2. Okay, substitute 2 into r, so I get 2 squared over 2 minus 1 over 2. I close the bracket. If you use your calculator, what you get is the value of 5 and 2/5. Okay, now I urge you to pause the video. Really, please pause the video and try these 4 questions now. Then I'll give you the answers very quickly. I won't explain them too much because it's just a basic method, but I'll give you a while to try this, okay? Okay, for A, if you've done your integration correctly, you get 5x plus half x squared minus x cubed. The limit is 2 and -1. You substitute 2 into x, okay, you will get this portion here. You substitute -1 into x, you get this portion here. If you use your calculator, you should get the value of 7 1/2. For B is similar. You integrate t, you get t squared over 2 actually, okay, minus 1 over t. Okay, so you integrate in this case. What they actually have done here is, instead of integrating directly, what they have done is they will expand first. So first you expand the brackets, you get t squared minus 2 plus t to the power -2. A squared minus 2ab plus b squared. Then they started to do the integration. So here you get t cubed over 3. 2 integrated with respect to t is -2t. Here power plus 1 divided by the new index, you get -1. Limits are 4 and 1. You substitute the 4 into the t. You substitute the 1 into the t. You get this and this. You use your calculator. Your answer should yield 15 and 3/4. Okay, for part C itself, similarly, if you integrate x to the power of half, you get 2/3 x to the power of 3 over 2. This integrated gives you negative x squared over 4. Limits are 4 and 1. Simple substitution, use this bracket and these brackets. If you use your calculator, you will get the exact value of 11 over 12. Okay, now this one, I think we do some simplification first. 2r over 5 over 3r squared will yield 2/3 r cubed. Negative r cubed over 3r squared give you negative 1/3 r. Then if you start to integrate, okay, so what we have here is this. If you notice, what they have done here is they actually factorize 1/3 first. You could do that, or you can integrate directly from this step. It will still work out, but never mind. Okay, they what I call factorize 1/3 here. Then what happens here is this. To integrate this, 3 plus 1 gives you 4. Okay, 2 over 4 will give you half. The other one, r integrated gives you r squared over 2. Limits are 2 and 1. Simple substitution will yield these two brackets, and if you use your calculator, your final answer will give you 2. Okay, now example 2. Example 2, okay, it's exactly the same as what we have done with example 1. The only thing now here is this, be very careful, okay, the limits, right, in terms of pi, so which A means that your calculator should be in radian mode. That's the first thing. Second thing also, we're dealing with what I call trigonometric functions, but we've already learned how to integrate those already, haven't we? Okay, so now, without much further ado, I'm going to do the example 2a. So 1 integrated gives you x. Cosine, okay, integrated gives you positive sine. Okay, so you get negative sine of x over 2. But don't forget, right, to differentiate, okay, inside the bracket itself. So x over 2, differentiated with respect to x, gives you half. So you take the sine x over 2 divided by half. Okay, and the limits are pi to 0. So we simplify a bit. So I guess x minus 2 sine x over 2. My limits being pi to 0. Then if you use the simple substitutions, you get pi minus 2 sine pi over 2 minus 0 minus 2 sine of 0. If you use your calculator, your exact value will yield pi minus 2. Okay, sine of pi over 2 or sine of 90 gives you 1 here. Alright? Okay, that's why in the end, if you press, you get pi minus 2. Similarly, okay, what we have is question 2b. So what we are attempting to integrate, right, from 0 to pi over 4 is 4 minus secant square 4x. So what I'll do here is, you integrate 4, you get 4x. Secant square integrated is tangent of 4x. Okay, don't forget to differentiate the 4x, which gets 4, and then what I'll do is to divide by 4 like this, and then my limits are pi over 4 to 0. Then what is left for me to do is to do the simple substitution of pi over 4 into x and 0 into x and x here. So what I do here is this, 4 times pi over 4 minus tangent. 4 times pi over 4 is pi over 4. That's my first bracket. Second bracket, 4 times 0 is 0. Then tangent 4 times 0 is tangent 0 over 4. Then this will actually yield for me is pi. Tangent of pi is 0. So in the end, what I'll get here is just simply pi itself. Okay, and that is 2b. Now, what you need to do is to pause the video, okay, and try to, please really do try to, and then when you're ready, unpause the video, and I'll give you the answers. Okay, for try 2 itself, similarly, again, 3 integrated gives you 3x. Sine x integrated gives you negative cosine x. That's why here becomes plus 2. Okay, and the limits pi over 2 and 0. Substitution by the values will yield 3 pi over 2 minus 2. Similarly, for part B, x integrated gives you x squared over 2. Cosine integrated yields sine x. Limits are 0 to pi over 2. You do the substitution, you get pi squared over 8 plus 1. Last but not least, similarly, okay, integrating 2 yields 2x. Secant square 3x will yield tangent 3x. Don't forget to differentiate 3x with respect to x to give you 3. So you divide by 3, hence the 1/3 here. Limits are from 0 to pi over 3. You put it into the appropriate, you put it into the brackets, you substitute x with 0 and pi over 3. You get these two brackets, and what you get is 2 pi over 3. Okay, now I'm going to cover with you example 3 itself. Example 3 is just applying what we have learned, okay, but now what we have is a definite integral. So first, for part A, what I'm going to do is I'm going to simplify this first. So it's ln over 2 and 0. So this is 5 over 3 over here like this. I am going to now express this guy as a index in the numerator, so I get is e to the power of negative 5x minus 2 with respect to x. Hence, what I will use here is e to the power of 2 minus 5x with respect to x. So now what happens now is this. I will now start to do, okay, to make my life a bit easier, I will factorize the 5 over 3. So I get ln over 2 and 0 e to the power of 2 minus 5x with respect to x. So if we start to do the integration itself, so first e to the power of 2 minus 5x integrated is still e 2 minus 5x. I will differentiate 2 minus 5x, we use negative 5. So I divide by negative 5. So I get this, negative 5. Then I close my brackets, ln 2 and 0. Okay. What I'm going to do now is to factorize out the negative 5 first. So negative 5, if I factorize this, it will interact with my 5 over 3. And this will give me negative 1/3 outside my brackets. What I'm left with here is e to the power of 2 minus 5x. Okay, from ln 2 and 0. What is left for me to do now is to just substitute in values. Negative 1/3 e, okay, to the power of 2 minus 5 ln 2 minus e, okay, to the power of 2 minus 0 is e squared. Alright. Okay, so if you want, okay, to further simplify this, okay, what I can do is e negative 1/3. Inside my brackets, I have e squared times e to the power of negative 5 ln 2. Alright, just applying the laws of indices here, minus e squared. So what I can do here is to factorize my e square. So I get negative 1/3 e square is e minus 5 ln 2 minus 1. Then, if everything is done correctly, if you key the calculator, you'll notice that this guy will yield e to the power, it will yield 2 to the power of negative 5. Hence, if everything is simplified, what I get is negative 1/3 e square, okay, 2 to the power of negative 5 minus 1. So, finally, okay, I know I'm writing over a place, my final answer will give me e to the power of negative 1/3 e square multiplied to this 2 to the power of negative 5 minus 1. Your calculator will help you to simplify everything, and what you get will be 31 over 96 e square. That's it. Okay, I think the basic concepts are not too difficult. It's more the manipulation itself. but not to worry. Okay, let's do 3b now, example 3b. So on example 3b, I'm integrating from the lower limit of 1 to 2, 2x minus 1 over x. What I can do here is this, 2x over x will simplify to 2, then minus 1 over x with respect to x. Then 2 integrated yields 2x, negative 1 over x, don't forget, will yield negative ln x. And my limits are from 2 to 1. Then what I can do is substitute in 2 times 2 is 4, minus ln 2 minus 2 times 1 is 2, minus ln 1, which you should remember is 0. So in the end, if you simplify everything, you get 2 minus ln 2. Okay, your turn to try 3a, 3b, and 3c. Please pause the video and give this a shot. Okay, if everything is okay, you can unpause the video and I'll go through the answers. Okay, e to the power 3x. If you integrate here, differentiating 3x gives you 3. So you divide by 3, get 1/3. The limit 0 to 3. You substitute in, you get 1/3 e to the power 9 minus 1. Similarly, okay, for part B, what you need to do is to simplify. Okay, so for this guy, what they have done is, first is written as 2/3 times 1 over e negative x minus 1. Then 2/3 for this term here, I can write it as e negative, okay, so negative x minus 1 will yield x plus 1. Then what they have done here is this, they will actually factorize this 2/3, okay, they put it out here, and what we're left with is e to the power of x plus 1 in the bracket. You substitute the appropriate values of 0 and ln 3, you get these two terms. Eventually what I get is 4 over 3 times e to the power of 1. Last but not least, okay, 3c itself. For 3c, simplification is done first. 2x over x yields 2. Negative 3 over x is this. You integrate 2, you get 2x. Negative 3 over x integrated gives you negative 3 ln x. Limits are from 2 to 4 rather. You substitute in the values of x equals to 4. Substitute in x equals to 2 here. You simplify. What you get is 4 minus 3 ln 2. Okay, now what I'm going to do is example 4. This will be the last example for this what I call portion of the textbook. So now what we have is 4, 1. So differentiate 3x, 1 minus 2x. So what we do here is, notice that this is of the form u over v. Hence, what we need to apply is the quotient rule itself. So now what I'll do here is, okay, part 1, u is equals to 3x. Differentiating u with respect to x gives you 3. V is square root of 1 minus 2x. So differentiating v with respect to x is half 1 minus 2x negative half, and then what we have here is times negative 2. So half times negative 2 will yield negative 1. So what I have left here is 1 minus 2x to the power of negative half. Hence, okay, if I differentiate that, what I will get is v du dx, so is 3 root of 1 minus 2x plus u dv dx, so is 3x over square root of 1 minus 2x divided by v squared, so it's 1 minus 2x. Okay, the simplest way to solve all of this is to multiply every single term by square root of 1 minus 2x. So if I do that and multiply every term by root of 1 minus 2x, well, I get my numerator is 3 times 1 minus 2x plus 3x over, in the denominator I get 1 minus 2x to the power of 3 over 2. Then if I simplify everything, I will get 3 minus 3x times, divided by 1 minus 2x. What I can further factorize here is 3, 1 minus x divided by 1 minus 2x to the power of 3 over 2. So very basically, when I differentiate this guy with respect to x, okay, what I'll get is this result here. Okay, why is this important? Because if you notice in part 2, they say hence evaluate. Okay, this and these are slightly different. Okay, how are they different? There is an extra 3 down here, like this, okay? Don't worry so much, okay? Let me just copy the result that we have, okay? So I copy, then I'll show you how we can use that result. So I paste. So basically, what I'm saying here is this. Just now, when I differentiated this, I will get this result, correct? So it goes to show that if I integrate this result, what I'll get is the original result there. So what I do here is 3x square root of 1 minus 2x. Okay, there should be a constant plus c because here I have no values, but once I fill it in, it becomes a definite integral. Okay, now what I need to do here is to do some modification. What are the modifications that I need to do is this. Notice that I want to integrate 1 minus x over square root of 1 minus 2x cubed over here. So there's the extra 3 I was talking about. So what I need to do to modify is to put in the 1/3 on the left. Why the 1/3? This 2, 3 will eliminate to give you just 1 minus x over 1 minus 2x to the power 3 over 2, which is what we actually want. Then, if I multiply by 1/3 on my left hand side, it goes to show that what I need to do on my right hand side is to multiply by 1/3 itself. Okay, then not forgetting that this is a definite integral, so I'm integrating from 0 to negative 4. So since I've integrated already, I will put here 0 to negative 4. Alright, okay, now next thing that I can do here is this 1/3. I start to put in the values. So 3 times 0 is 0 over square root of 1 minus 0. Okay, minus 3 times negative 4 is negative 12 divided by, here is square root of 1 minus negative 2 times negative 4 gives you this square root of 9. So if you just calculate everything, what you should get is 4 over 3.